everyone, and welcome to this first time live session with Dr. James Wertz on Hyperbolic Orbits podcast. I know he's someone who needs no introduction, but for young people who have still not started reading his books, I would like to introduce him in a way that that much I'll try to be capable of. So Dr. James Wertz is a leading figure in space mission engineering. He's recognized for his profound impact on making space exploration more accessible and cost effective. As president of Microcosm, he has been a principal innovator in developing practical solutions for low-cost space launch systems, autonomous navigation, and satellite systems. An adjunct professor of astronautics at the University of Southern California, Dr. Wertz is currently teaching a unique course on commercial lunar settlements. He's the editor and principal author of several seminal texts that have become standard references in the field of space exploration, including Spacecraft Attitude Determination and Control, and the widely used Space Mission Analysis and Design, and the new SMAD. He has taught his methodologies to a global audience of professionals and students, sharing his expertise in mission design, orbit and constellation management, and cost reduction. And he continues to explore the future of space through his work and writings for spacenews.com. Dr. Wertz, thanks a lot. I'm really grateful that you're here today.
Thank you very much. I'm happy to join you. This should be very enjoyable, and I appreciate the opportunity.
Thanks a lot. So my first question to you is about, of course, space mission analysis and design. So it has been going on for so many decades. So what really made you start this really, really complex initiative? And what are the challenges that have you faced for so many decades?
Actually, it's the story really starts with the other book you mentioned, Spacecraft Attitude Determination and Control. That's actually where it got started. And the way all this got started is actually a slightly interesting story, I think. When I got my PhD, thousands of years ago, but in any case, at that time, the government had largely stopped spending in physics. My PhD is in theoretical physics, general relativity and cosmology, which is another way of saying I'm useless to all of humanity. It has no practical value whatsoever. But in any case, at that time, the government has stopped spending money in physics. And so there were 10 jobs in theoretical physics in the entire United States. So basically, there wasn't anything, to say the least. I ended up, after some other activity, working for the Attitude Determination Department at Computer Sciences Corporation, that was a contractor to Goddard Space Flight Center. And it was basically a choice. I wasn't all that interested in space, but it was a choice between that and driving a taxi, and that seemed probably better. The interesting thing about this, however, is that the Attitude Determination Department at CSC had about 150 people in it, about 75 of whom had PhDs in physics. And the reason for that was that you could buy physicists at 3 for $10 and get change. They had no value whatsoever. They didn't know anything about space, but they were really good at math. And so as a consequence, they ended up developing a lot of some of the basic mathematics associated with attitude analysis for spacecraft. Obviously, orbit analysis for spacecraft, that was developed by Sir Isaac Newton. I mean, he invented the calculus to determine the orbit of the moon. I mean, that was what he was doing. So the orbit analysis has been done for many, many, many years. But the mathematics behind attitude analysis, by and large, didn't exist. Well, Goddard Space Flight Center was going to renew the contract with CSC and go out and put the contract out for bids. And so they told CSC to write a group of white papers on the basis for attitude analysis. And I went back to Goddard at that point and I said, a batch of white papers really aren't going to do you a lot of good. What you need is a book. So you all put it together as one piece so it all makes sense together. And they said that was fine. And that was what led to the creation of the attitude book. That one actually is still in print. In fact, it's still being used at some level because it does contain most of the basic mathematics. And a few years after that one came out, then Dr. Wiley Larson at the Air Force Academy came to me and said, we need to create something that is a textbook for space activity. There isn't any good textbook. We need to create some sort of a textbook. The attitude books seem to work pretty well. Can we do something of that sort? And that's what led to the creation of SMAD. So we sat down and said, okay, what do folks that are starting out in this arena need to know? And, created 3 editions of SMAD. Now there is a space mission engineering. So SMAD actually is, it's still in use, but it's going away because in some sense it's old. And space mission engineering is the new substitute for that. That's been in use for quite a while now. So long story long, actually, I apologize for talking so much about it, but that's basically the background.
That's quite a story. Thank you for sharing that. And my next question is also related to this. The attitude, determination, and control you are one of the pioneers in that field. And a quite widely discussed topic these days is the role of current level of artificial intelligence technologies in autonomous ADCS. So what are your thoughts on that?
I got to say that I'm not very much in favor of it. The artificial intelligence in spacecraft makes a huge amount of sense, but it makes an enormous amount of sense primarily associated with the payload and observing things, determining what they are, what data should I send where, all that kind of thing. Using it for the spacecraft control activity, I don't think makes as much sense. The spacecraft control, after all, is by and large well determined. I mean, what it is you want to do is pretty clear. And I don't really need to have any additional artificial intelligence associated with that. I want to have software for sure. I don't want to have fairly complex software solutions, but they can all be well defined. But as we all know, in AI, mistakes happen. I mean, there are accidents for AI-driven cars. There are problems with it being used for training people. There are all kinds of things that can potentially go wrong. And what I can't afford to have happen is something go wrong with the control of the spacecraft. That clearly, we could end up obviously losing the spacecraft and losing the mission. If something goes wrong with one of the payload analysis activities, I'm identifying forest fires and I mistakenly identify something as a forest fire that is not, that really has done me no harm. And so using it for the payload analysis on board can dramatically increase the potential of getting things done, enormously valuable all the way around. Controlling the spacecraft, the mistakes are pretty expensive. And so I would suggest that it probably is not a good thing for spacecraft control. Does that make sense?
Thank you. Yes. A lot of people also argue that it may help because in deep space missions, you need a higher level of autonomy. So maybe that there it will help. So do you think there?
I would agree that you need a high level of autonomy. I would not argue in any way at all that it shouldn't be autonomous. I think autonomy makes an enormous amount of sense, but I don't think it has to be AI autonomy. It can be autonomous doing its own thing with well-defined software. And so I would still argue that even in, I don't know, Mars missions or Jupiter missions or whatever it may be, certainly they want to be autonomous. They will need to be autonomous. And indeed, I'm sure your readers all know that, for example, when you're landing on Mars, by the time you get the data back that a mission has started, it is already on Mars. So there's nothing I can do. It has to be autonomous. There is no question. And I certainly want it to be, for sure. But again, I don't think that I do not regard AI as being autonomous, as being the same as being autonomous.
Thanks a lot. And now A major section for today's session is a very interesting course that Dr. Wertz has been teaching at USC. So I would request you to kindly tell us more about the course. And this is a place where audience interaction is very, very appreciated. So please feel free to unmute yourself. And while Dr. Wertz finishes explaining what he's teaching and when he's asking, so please introduce yourself and ask him your questions or on the comment box. So Dr. Wertz, the floor is yours.
Sure. And by the way, if people want to interrupt, that's fine. Delighted to have people interrupt with questions. No doubt about that. The course that I'm teaching now arose from a course that I have been teaching for 25 years at USC in the design of low-cost space missions. As you can well imagine, most low-cost space missions are relatively small spacecraft. They're not big, large missions. They're small ones, and then they have become obviously much more popular now over the course of the last 10 or 15 years or so. And indeed, you might say that small spacecraft are almost dominating the spacecraft arena these days. That's a good thing. One of the things that I wanted to ask in the course was, can I apply these same rules that make small spacecraft work to missions that are inherently large and expensive? And so I decided to try, for example, the largest and most expensive mission I could think of, which was a colony for 1,000 people on the moon. Sounded like inherently probably a fairly expensive mission. Can we do anything to make it cheaper? And it turns out, yeah, we can. Some of the rules for small spacecraft apply, some don't, no question. But can we find ways to make that mission low cost, near term? And there are several things that can be done. We need low cost transportation. SpaceX is working on that at the present time. Their last flight was apparently fairly successful. I also need two other things. I need to make it low cost in terms of the stuff that I'm using on the moon. By and large, the stuff that I use on the moon is developed specifically for the moon, is hugely expensive to develop it, and takes a long time. So as a consequence, what do I do to make it cheap? And the answer is, I build a lunar enclosure and I work inside instead of working outside. So I change the nature of what is done. If those of you, I don't know, nobody out there as old as I am, but in any case, you may remember there were what are called space colonies done by Gerard O'Neill back in 1974. And these were huge colonies out at the L4 and L5 Lagrange points, where people lived in 1G environment in a big rotating space station. It's 30 kilometers long, 3 kilometers in diameter. What we want to do is to do something similar to that, except put the colony on the moon and make it 1,000 times smaller. Putting it on the moon, of course, means it's now next to your resources. And that's where I'm getting the stuff from to build it. The aluminum, the glass, things like that, I'm getting it on the moon. And it's relatively simple to build an enclosure because, first of all, it's 1/6 G. There are no storms. There are no hurricanes or tornadoes or floods or whatever the case may be. And obviously, it's 1/6 G. Everything is lightweight. So if I build an enclosure on the moon, suppose I use maybe 2 millimeter thick aluminum, some of that sort. I build an enclosure. And I cover it with regolith, maybe 2 meters of regolith all around it. That's for the purpose of cutting out the radiation from space and, of course, the thermal environment. I want to make thermal, and inside that enclosure, I'm going to have radiation environment, pretty much the same as it is on the surface of the Earth. I'm going to have a thermal environment, which again is very normal Earth-type thermal environment. So I now have a relatively easy environment. The enclosure itself, by and large, pretty easy to build. Basically, I've got, let's say, 2 meters of regolith on top, which is, I don't know, roughly 15 psi of mass on the Earth. So on the moon, it's 1/6 of that. So it's maybe 2.5 psi on the moon. but I have 15 psi of air inside, which is still 15 psi on the moon, pushing out. So really what I'm building is a balloon. So you've sometimes seen pictures of construction on the moon with big cranes. And this is much more like putting up a circus tent. It's relatively small, comparatively thin. I've got to do welding, of course, so I obviously want to make it airtight, of course. But it's a relatively very simple thing to build. And then all the equipment that I need. My iPhone works on the moon. Cool. Microwave oven works on the moon. You know, all the stuff that you're working, the computer that we're talking on now, works on the moon. How do I make it work? I plug it into 110 on the wall, or maybe 220. I don't know whether India is on 220 or 110. But in any case, I just plug it into the wall and I make things work. I use, the dishwasher that I buy from the local store. I use bicycles and so on. In fact, instead of spending $50 million or whatever it is developing a bicycle, I could do one of two things. I could go to the local corner store and buy a bicycle. Even better, I could go to the bicycle manufacturer and I could say, if you would pay me $100 million, we'll use your bicycle on the moon and put your name and big labels on the side and da-da-da, and make money from it. And that makes an enormous amount of sense. So the major activities become, let me call them social activities, for lack of a better word. And by social activities, I mean things like lunar tourism, lunar burial, lunar education. Think of education, for example, in two forms. One is graduate students going to the moon, doing projects and stuff like that. But the other is educating 8.2 billion people worldwide on living on the moon and expanding into the solar system. And so you think now of Portugal, good example. Portugal is going to have an ambassador to the moon. What's the Portuguese ambassador to the moon going to do? Well, he's going to spend a little bit of his or her time taking care of one or two Portuguese that might be there per year. There aren't going to be very many, of course, but there might be one or two or something of that sort, and they undoubtedly need a lot of attention, without a doubt. But much of his or her time is going to be spent talking to students in classrooms in Portugal. And obviously, critically, in Portuguese. Not in Spanish, not in French, not in English, in Portuguese. Because he wants to tell them about the importance of Portugal being a part of the expansion into the solar system. So, and obviously we have, roughly 200 countries worldwide, 150 different languages. That's an awful lot of lectures, an awful lot of discussion going on. Think of this podcast. If one of us was on the moon, it's about a 2-second round trip delay, so you'd know it in the conversation, but doesn't keep the conversation from occurring in any way at all. But it would be an enormous conversation, a remarkably interesting one to most of the world's 8.2 billion people. And so there's an enormous amount of time spent there. Advertising and marketing, obviously, would become a very large thing because the audience is enormous. That's one of the things we were talking earlier, just before the podcast, about my interest in trying to get some students, graduate students from India, to join the next version of the course. I would love to have it, because what I would like to get is the perspective of what is of value to people in India. I've already gotten that at some level. I had one student that got in touch with me and was talking a little bit about India. I was talking to her a little bit about what was of interest in India, and I changed some of my charts because of it, because it was a different perspective. And that is enormously valuable, because we're not talking now about technology. We're talking about social issues. And those are the things that are interest. I don't know. Nobody thinks much about what's a squirrel going to do on the moon. But that's a very interesting issue. How are plants, the whole idea of gravitational biology is not only interesting, but frankly important. If we're going to have people living on the moon or on Mars or anywhere in space, I need to understand what gravity does to various elements of biology. Does wheat grow the same as barley? I don't know. Nobody knows. What's the difference between 1/6 G on the moon, a half G on Mars, obviously full G on the Earth, more or less on asteroids or the moons of the various planets and so on? These are the things that we need to understand. So a lot of gravitational science is there that we need to do. And as a practical matter, we can't do that on the Earth. We could do it on the moon. We could do it in space. Do either of those. But I certainly cannot do it on the Earth. And I need to do that if I'm going to expand out into the solar system. I need to understand how this really works. There was a lot of issue about not raising kids in 1/6 G because they wouldn't be able to come back to Earth. That may be true. I don't know. It may not be true. Again, we do know that adults at least have spent a year and a quarter in space, come back and been fine. So my guess is you could reason, if you can live in 0 G for a year and a quarter and not have it bother you too much, I'm assuming that full-size adults could probably live on the moon for, I don't know, maybe 3 years or something like that. So who knows? And then maybe they have to go back. Could they live longer than that? I don't know. But that's one of the things you want to try and find out. You clearly want to have among the people that are among the very first colonists on the moon are going to be medical doctors doing both science and medicine. What happens if somebody has an appendix attack? Well, I got to do something, right? I mean, I've got to have doctors available out in space. And they're going to have to learn to do things. Now, the moon is a great place to learn because, for one thing, they have immediate access to essentially any doctor that they want back on Earth. Again, 2-second delay time going back and forth, not a big deal. So as a consequence, obviously the doctors that are on the moon are not going to be familiar with all of the medical sciences. They don't have to be. They can learn things as they go. So to me, at least, the lunar settlement would be remarkably much fun. Think of romance in 1/6 G. Would be a remarkable time all the way around. The view of the Earth, being on the moon, looking out the window at things that are 100 million years old. The one I like, I think I had sent you the picture earlier, was of somebody jumping over a small building on the moon. My best guess is that the average adult can jump probably 20 feet in the air, maybe a little higher. And it means the jump will be maybe 100 feet long or so, which means they could easily jump over a small building. That would be kind of neat. That would be neat to see. It would be neat to eat. Now, you get old fogies like me, and maybe I can jump over a small doghouse. But that's okay. It's still fun to see these things happen and to watch these things occur. Think of some of the dancers, for example, that are quite remarkable at being able to do that in 1/6 G, but staying in the air for maybe 4 seconds. That would be quite remarkable. So in any case, that's what the course is all about. Does this make sense? Can we make it work? What do we have to do to make it work? How do we make it occur? Oh, I forgot one thing. Another major difference is it wants to be two things. It wants to be commercial instead of government run, because I want to be able to make profit and make things move quickly and move along rapidly. It also wants to be international. That, I think, is obvious. I think there is interest around the world, and it clearly wants to be an international activity. So that means if I've got a colony of, let's say, 500 or 1,000 people on the moon, they probably speak 150 different languages. That's an interesting challenge. Okay, how do they, which side of the road do I drive on? I mean, how do I do this in a way that makes sense? Because I'm going to have people with remarkably diverse backgrounds living and working and touring and visiting on the moon. And I need to find ways to have them interact. Again, it becomes much more of a social problem than a physical problem. I'm not so much concerned with the mechanics. And what the hell? I can make a dishwasher work or a clothes washer work. That's not a problem. I can use the stuff that I've got here on the Earth. But now I have a different environment for people living and interacting with each other. And that's going to be interesting. It's hard to do here on the Earth. With luck, it would be easier on the moon, we hope. But, that's what we have to make work. Questions, comments? That's a quick summary, at least. And I apologize for running a little long there. But questions, comments, nasty remarks?
Yes. Thank you. Thank you. We have one question saying that I'm a biotechnology student. What technical or analytical skills should I learn to work at the intersection of space research and life science?
Oh, well, basically, the question that we want to look at is what is the impact of gravity? So what I need to do is to be able to do analysis of various elements. Let's describe in particular what would probably be occurring here if I'm on the moon. I have a gravitational biology wheel. It's basically a wheel. It's rotating around. Parallel, the axis of the wheel is perpendicular to the moon's surface. And so it's rotating, and the further out I go, the greater the artificial gravity. So if I'm right at the axis, of course, it's 1/6 G, I'm on the moon. I can go a little bit further out and get a half G, Mars. I can go a little further out and get 1 G, and so on. And what I want to do is to do experiments. So I need to understand both the statistical process and also the process of conducting experiments. I'd like to be able to raise wheat and barley and oats in 1/6 G, a half G, 1 G, and try and see what the differences are. Do they all grow the same? I don't know. We don't know whether or not these things grow the same on the moon as they, maybe, I don't know, who knows? Maybe barley becomes a lunar crop because it grows particularly well. We have no way of knowing. But those are the things that we want to try and understand. So those are the things that we want to be able to study. Be able to study and look at. And of course, it's not only plants, it's also animals and people. How do various animals work at various levels of gravity and so on? Do some respond very well? Some maybe respond very poorly. We don't know. And of course, there's a huge amount of medical experiments. It could be that, sooner or later, there are going to be kids born on the moon. It's going to happen. So what do I want to do? Do I want to have those kids spend a large part of their life in artificial 1 G? Maybe a half G? I'm not sure what works. Clearly, I want to look very closely because we don't want to endanger anybody, of course. And so part of what we want to do is to watch for what are the problems that are occurring. How do I go about solving them? Are they just psychological problems? Are they physiological problems? And how do I go about determining that without, of course, endangering the kid that's born on the moon? It's not his fault or her fault. But, how do they grow up in a way that makes sense? In any case, does that answer make sense?
Thank you. To me, the person who asked this question, I would ask if that answered your question. It's a very interesting and relevant one for this segment. And we have another very interesting question, which is, how important do you think it is for space engineers to also be trained in economics and business principles to be ready for a burgeoning cislunar commercial economy?
I would be inclined to put it the other way around. That is to say, how much astronautics training do I have to give to the people that are living and working on the moon? The tendency is to think of the people in space as being astronauts or selenauts or cosmonauts or something of that sort. I would much rather think of the people on the moon as being people, you and me. And how much training do we need in astronautics? Depends on what it is we're doing. An obvious example, I'm going to have some tourists on the moon. There's going to be a lunar Marriott or something equivalent, something like that. Okay. And I don't know, given the transportation costs that SpaceX can probably get and stuff like that, it's going to be an expensive space tourist, to say the least. Probably cost them $1 million to spend 2 weeks on the moon. Okay, so obviously it's going to tend to be fairly expensive for most people, to say the least. That said, somebody's got to sweep the floor, make the bed, and clean the bathroom. That's not a high-tech activity. It doesn't have to be an astronaut to do that. But somebody's going to do it. I mean, the guest isn't going to do it. You're not going to spend $1 million to spend 2 weeks on the moon and make your own bed and vacuum your own room. Okay, so you're going to have somebody doing that work. Somebody obviously is going to be the cook. Somebody's going to be raising food. All these kinds of things. These are skills for which I don't need to be an astronaut. I don't even need to know how to wear a spacesuit. I may. It may be that in their spare time, because remember that ordinarily you work about 1/3 of your time and 2/3 of your time you're sleeping or doing other stuff, whatever it may be. Now, I expect that a large number of people that are on the moon will want to put on a spacesuit and go wandering around outside just for the fun of it. You know, it's just like you go to Hawaii and you spend time at the beach. Okay, so yeah, but do I have to do it for your job? No. I do it because it's fun. It's fun, it's interesting, exciting. And the same thing is true with people that are doing astronautics. You know, they can learn some things, not learn other things. That's fine. They can go out in tours. Riding around around the Copernicus crater would be a lot of fun. To me, at least, one of the more fun things is, as I think most of you know, the large craters on the moon, Copernicus, Tycho. Tycho, by the way, is a great place for lunar burial because you can see it from the Earth. You can identify it. It's where all the rays are coming out from. And Tycho, Copernicus are both, I don't know, 80, 90 kilometers in diameter. The outer wall is around 15 kilometers in length and is downhill about 2 kilometers, about roughly twice the depth of the Grand Canyon in the United States. And it has these rolling hills going down that 2 kilometers. That would be one hell of a ride. Think of a ride in a car that's traveling. By the time it's going back and forth, probably the better part of 100 kilometers, and this downhill ride going back and forth in 1/6 G would be a remarkable roller coaster. Let's put it that way. So, you know, that sort of thing would be an enormous amount of fun. And those are the sorts of things that we want to think about. What will be fun? What are the things I have to do? And what I have to do is I have to make the beds. I have to clean the bathroom. I have to, do construction inside. Small things, of course. I mean, things like tables and chairs and so on. Well, I build them out of aluminum. I've got aluminum on the moon. What a deal. So what do? I have an aluminum table. Got it. Okay, that's fine. Things that are more complex, a microwave oven. I bring it up from the Earth. Bring it up, plug it in. It'll work on 1/6 G just fine. All that makes sense? I'm not sure if I answered your question or not. No, you can ask again.
They've said that thanks for your answer. I guess my question was more in relation to the design engineers who are going to be designing since lunar infrastructure. My general sense is that to make it such that technical designs are also economically viable, engineers need to be able to evaluate not just the technically optimal solutions, but also the design options that maximize economic viability. Thank you. So
Yes. Okay. I agree with you, sort of. Only sort of. On the one hand, what you're saying is absolutely correct. I obviously have to understand the economics. No question about it. But think about architecture on the Earth. The number one priority does not tend to be cost. Is your home made in the cheapest possible way? It's probably not. The cheapest possible way would be just a simple rectangle, right? Simple rectangle, windows all the same all the way around. Doesn't tend to be the way things actually get built. They get built in part to look pretty, to be interesting. Think of the Colosseum in Rome. It is not necessarily made the most economical way. It's made in a way that looks pretty. And that's a part of what it is we want to achieve on the moon as well. So yes, I would agree. Your comment makes sense. And indeed, if you look at the literature, all of the discussions of architecture are all in terms of economy. How can I do things economically? I am convinced that one of the rules of being, if you're in the technical side of it, of being an astronaut on the moon is you can't be more than 6 feet tall because they want to make the ceiling low height. I mean, they want to drive the cost down. And to me, at least, that's not the key issue. That's one of the reasons I had that picture of the lady jumping over the building, is because to me, there will be two answers to that question. There will be people, I don't want to say it, people that are oriented in socialists, look at it, wow, that's neat, that's amazing, da 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 da. There will be astronauts or astronautics engineers who will go out and say that's total bullshit. Nobody would ever build an opening that high. People can walk, after all, in something that's 8 or 10 feet high. Why would I ever want to build a room that is 30 feet high? And the answer is because I can jump that high. And people will want to try jumping that high. It will be fun. It will be a part of being people. So yes, I want to make it economical. That is certainly true. So I do want to look at the economics, and I agree with you entirely. We clearly want to understand the economics of the process. And so having at least some training in economics makes a huge amount of sense, without a doubt. Really do want to understand that for sure. But I don't want that to necessarily be the driving characteristic. Was economics the driving characteristics for building any of the big government buildings that you look at, for example? I mean, most of them tend to have architectural features that are not necessarily economical. They are there to be pretty. They're there to demonstrate the robustness of the people that build it. One of the things I think that will occur on the moon is we'll get what I call ranches, for lack of a better word. That is to say, somebody that's got a lot of money is going to go build their own small colony, not attached to the big space colony or the big settlement, but maybe 100 yards away or something like that, where they can invite people to come and visit, either for social reasons or business reasons. I'm running this business meeting on the moon. Would you like to attend? An awful lot of people are going to be nodding yes to that, right? And they would like to have their own facility, just like they would like to have their own facility in India, in the United States, anywhere else. That makes sense, right? And they get in a vehicle of some sort and drive over. Maybe have dinner over the big colony. Maybe have dinner in their ranch. Who knows? But they build their own separate place because, for one thing, they can afford it. What do people that are rich do now? They buy yachts. Why do they buy a yacht? Because they really like being out on the ocean? Probably in part, and in part because they want to have a yacht because it shows that they are rich. Right? And I would argue the same thing is going to be true on the moon. Why would
Thank
you
you.
build a place? Does that make sense?
Yeah, thanks a lot. Um, okay, since he's saying that he's on the road, which is why he can't unmute, unfortunately, and he says thank you to you. I would just like to mention the person who asked this question is actually one of the most brilliant space experts that I have also met. He's more experienced than me, far more, but I would still consider him in the rather young category. In he loves space. He works in the industry, and he's asking you because I know that he's genuinely interested and knowledgeable in this subject. So thanks a lot. Since he cannot unmute, I would like to thank you for that. We have a couple of more questions. Um, but before taking the question on the comments, shall we give the opportunity to the person who has raised a hand first? Yes, please, Nimisha, unmute yourself here.
Hi, thanks, Sumna, and hello, Dr. James Wertz. I'm Nimisha Mittal. I actually worked at JPL for many years. I worked with Julie on Insight as well. It's a pleasure to hear you speak here, and very interesting to hear about the economic and cultural aspects of lunar colonization rather than just the technical challenges that we often think about. My question is, as we start to colonize the moon, how many years?
I'm sorry, can you back up once? You broke up for a second. You broke up for just a second. Back up and go ahead.
Sure. My question is, as it's been very interesting hearing you talk about the economic and cultural aspects of lunar colonization, which in my mind would come a little bit later after we start developing infrastructure on the moon. I'm curious if there's an idea or estimate of how long it will take before we overcome some of the major technical challenges of establishing human presence first, and then potentially going to developing the infrastructure in a way that is culturally and economically inspiring.
I like your question. I think absolutely the right question. And I think the answer is we can do it now. All I really want to do, there are two ways I could do this. I could go send robots to the moon, and I could develop robots that could do their own independent thing, and they may or may not be able to do it very well. But people can do things virtually immediately. Building the enclosure, for example, is something that I could do that today. I don't need anything. And let's suppose that I send, I don't know. Let's be simplistic. SpaceX could probably put 50 people on the moon, more or less, in one or two flights fairly easily. Okay, what do? All right, well, they can either live in the ship that they brought them, or you could have an inflatable colony for a while. And you have, what do I have? I've got some doctors. I've got a couple of tourists because they're willing to pay $10 million to be the first tourists on the moon. I got probably 5 or 10 of those people are construction workers, literally construction workers, who are taking regolith and creating aluminum and glass, and they are building an enclosure. The first enclosure, maybe a little smaller, a medium-sized enclosure, in my mind, is about the size of a football stadium, give or take a bit. So, I don't know, let's say, for example, 100 to 300 meters in diameter, maybe 10 meters high, something like that. It's literally just a round structure and it has flat roof. I don't have any need for anything other than a flat roof. It doesn't rain. I don't have to have rainwater running off. Okay, I'm going to cover it with regolith around the sides and around the top. So all I have to do is literally build this thing out of aluminum and weld the pieces of aluminum together, and presto, I build a structure. I've got windows in it. Now, remember that on the moon, the Earth is fixed in the sky, pretty much. Not absolutely fixed, but pretty close at least. So I've got one really big window in a conference room that's looking out over the Earth and the rest of the surface of the moon. That would be one hell of a place for a conference, to say the least. All right. So I've got that one. I don't want too many of those, though, because after all, I do get radiation in through the window. So as a consequence, I also have a periscope window, which is literally a periscope that I look in and I look at an angle and it goes up and looks out. And so I have a periscope that can look out over the surroundings. Or I have an electronic window. I've got a camera, just like your camera that's sitting outside your garage door looking at the front yard. I have a camera. It's a whole set of cameras around the top perimeter of the enclosure, and a TV inside that can look at any one of those cameras. And so that becomes a window for the outside. So I don't think that building this enclosure is all that hard. And once I build the enclosure, now I can start to use things that are here on the Earth. As I talked about before, a bicycle. I mean, if I want to get around inside something the size of a football stadium, a bicycle is probably good, or maybe a golf cart, something like that. Okay, well, I've got those. I don't have to reinvent them. Right? I mean, there isn't much that I have to go invent, because almost everything that I use today, I could use on the moon if I'm inside. So I don't want to be, you may have seen those photos. You said you were at JPL for a while. You've seen those photos of people on the moon and they've got this 6-wheel vehicle. Mm-hmm. That's the sort of the standard lunar vehicle in some sense, has 6 wheels. What the hell? Come on. I can drive over the entire Earth in a 4-wheel vehicle. You know, we've got 4-wheel vehicles that are getting around in deserts and mountains and terrible terrain and all that kind of stuff. I can use a 4-wheel vehicle on the moon. I mean, a part of that, of course, was for the purpose of demonstrating how different the moon was. Well, it doesn't have to be that different. I can use the things that I use here. So yes, so I'm saying that from a commercial perspective, I think we could start building the first lunar settlement roughly in 5 years, have a full enclosure, a couple of them in maybe 10 years' time. It takes a while, obviously, to build things and get it settled and stuff like that. You would always like to build, in my mind at least, safety, of course, is always a key concern. So, for example, I don't want to build one enclosure, I want to build 2. Mm-hmm. Make sense? Because no matter what, there's always a danger. Somebody leaves the door open. I mean, what the hell? There are ways that I lose air. What I want to have is at least 2, maybe 3 places that can accommodate the entire population. Because again, I want to be safe. Always want to drive safety as a key issue. But I don't think that means that we want robots doing stuff for us.
May I ask a follow-up?
Sure. Did I answer your question, by the way, or not?
It's definitely an interesting way to look at the issue. It's not something I've thought about a lot, so I think I'll be processing the information for a little while. But I see your point about how we could, I mean, we have the technology. It's really just a matter of people who are building this infrastructure deciding to do it on a bigger scale rather than in a potentially like a test isolated demonstration kind of method. So in that case, for Mars settlements, we have been talking or hearing a lot about robots being sent to Mars to build a lot of the infrastructure. Would that be necessary for the moon as well, or do you foresee all of that?
To be honest, I don't think so. Let's see. You're along. Well, you were here at JPL. The fires that occurred in Los Angeles. I'm not sure how familiar you are with those, but maybe what it was 8 or 9 months ago, there was a set of very large fires. And they were in the vicinity of JPL, actually. They were not literally at JPL, but a lot of folks that worked at JPL lived in these towns, lost their homes, stuff like that. And obviously, it's an enormous problem. The rebuilding process is ongoing. But you'll notice that JPL did not come to the county of Los Angeles and say, oh, we'll build you a robot that will rebuild all these houses. Why? Because it would have taken them 5 to 10 years to build those robots and then to start rebuilding the houses. And that isn't what they wanted to have done. And I think the same thing is true on the moon. It isn't. Could a robot build a structure? Maybe. Could a robot help build a structure? Yes, for sure. There is no question that some combination of people and robots make a huge amount of sense. That makes an enormous amount of sense. But having things done completely by robots, lots of things can go wrong. Sweeping the floor. There are all kinds of machines to sweep, automatic machines that will sweep the floor now. Okay? Will they sweep the floor entirely and completely? No. They will get stuck under the sofa. They won't be able to clean the corner very well. The robot working with a person works really well. Another example of that, actually my cousin's sister corporation, the Scorpio Space Launch Company, built the first commercial propellant tanks on the moon. We do understand lunar problems and stuff like that. We built stuff, we've got it on the moon, it's there, they're working. The mission itself was IM-1, did not work very well. It fell over on its side. Well, I can either try and build a spacecraft that cannot fall over, or if I've got a lunar settlement with people living in it there, somebody puts on a spacesuit, goes outside, stands it up on end, and goes back inside. Takes them an hour. Okay?
Yeah, that makes
sense?
Yes, yes,
People working in conjunction with automatic systems work very well. I mean, I'm not trying to say we want to eliminate automatic systems. I don't think that's true at all. I mean, it's an enormous value, and I can add a lot to it. The best answer, I would argue, as is true for many space systems, frankly, is some combination. I'd like to have both people and mechanical issues, so I have backup. Since the mechanical doesn't work very well, the people can do the work. If the people are having trouble with something, maybe I can find something mechanical that will work. I can reduce the cost. I can increase safety by using mechanical issues. That makes a lot of sense. I certainly want to do that. But I want to find something that is a combination of people and automated issues. Does that
would be good.
Okay. So,
Yeah,
but yes, that's the sort of thing I would argue that we would want to do and that we could do in the relatively very near term. It doesn't take much to be able to do that. Because, I mean, I've got to have a welding machine that can work by itself and go off and, weld these various pieces of aluminum together and stuff like that. Okay, I mean, that's an automated process. Should be. Is it going to get stuck occasionally? Yeah. And when it gets stuck, somebody's going to have to go, fiddle with it a little bit and get it working again.
We need the mechanics there to keep.
Right, exactly.
Yes.
And you need somebody. And so the answer is, do I need a mechanical engineer? Sure. I need somebody that understands mechanical engineering and understands machinery and that sort of thing. Absolutely positively want those people with those skills for sure. And I do want the mechanical parts, but I also want the social parts of it. Right? I mean, the guy that's out there working, building the colony, goes inside, he spends, 50, 60 hours or something like that working outside. It means in a week's time, he's spending 100, 110 hours inside, and he's doing something. Right? He or she, I mean, they're talking to people from other countries around the world. They're trying other kinds of food. They're talking to the biologist that's working on whether or not wheat or barley grows better in 1/6 G. Right? I mean, all of this is going on, and it's going on with people working together.
Yes,
which is
absolutely.
hard. In some sense, it's not unlike the discussion that we're having right now. There are different people with different skills, different interests, and how do we make all that work together? And certainly settling the moon is going to be a very international activity. Very, very much so.
Has to be.
If you don't mind, I'll give you one more example here really quick. I mentioned before there was one Indian student that contributed to the class that I appreciated very much, which is an aside discussion. They weren't in the class directly. But in the class, I was looking at what were the things that would be of interest to people. And I said, oh, one of the things that would be of great interest to people would be weddings. And I have 3 daughters. And I talked to my 3 daughters, and all 3 of them said, you're an idiot. That doesn't work. That what you want to have at a wedding is to have people there, and it's a family affair, and it's all that kind of thing. No, we're not going to have weddings on the moon. I talked to a lady from India who was saying one of the things that people in India enjoy, and I may be correct, you can tell me, is large weddings being televised. They are major events. They get an enormous amount of interest, a huge amount of television coverage and all that kind of thing. That a really big wedding would indeed be something on the moon that would be exciting and would generate an enormous amount of interest in India.
Yes, I would completely agree. I'm sure others on the call can weigh in as well, but weddings in India are a big part of the economy and the culture. So
that makes good sense. That sounds good. I appreciate the comment very much. It's very helpful. What I did is I put weddings back in my list of ceremonies and things to do on the moon, because they sounds to me like, at least for a good part of the world, they would be of interest.
For at least 6. Yes.
Right. And so, hey, cool. That's neat. And that's the sort of things that I want to understand. What is it occurring on the moon that would be of interest to people in India? I suspect a lot of it is in common to what would be of interest to people in the United States, and of course some of it is not. And that's what we want to try and understand, because it is something we have in common, right? I mean, people in the United States understand the moon, sort of. Frankly, probably not as well as many people around the world. But I mean, everybody knows the moon. People in India, China, Brazil, Kenya, all understand the moon. And having that conversation with somebody who was on the moon would be truly fascinating, I would argue, for a very large fraction of the world's population.
That's a fascinating way to think about what being on the moon would be like, because until now, to be frank, I had only heard scientific justifications of why we need to set things up on the moon for manufacturing and scientific gain. But eventually, I think as we expand into thinking about like what it means to be human on the moon, we'll have to think about all these other things.
Your comments, I think, are exactly right. That's exactly right. All of the traditional stuff is all about the science that I'm going to do on the moon. Well, I don't want to say the science has no value. It obviously has considerable value, of course. The observatory on the backside of the moon would be able to see stuff that nobody else has ever been able to see, to say the least. Looking out into the sky, that would be an enormous thing. But the real value, now I mean specifically economic value, real live money, has to do with the social characteristics, the advertising, the marketing, the tourism, the lunar burial. Being able to bury people on the moon in a place where you can see them all over the world. And you can truly see them all over the world. So there's something about that is very compelling, at least for some people. For some people, obviously, and sure not. But of course, there are a lot of people being buried. So, doesn't have to be of interest to the entire population, to say the least. But yes, the social issues, I would argue, can come into play essentially immediately. They don't have to wait for a robot system to go off and do some great and wondrous thing. For one thing, inventing the robot system is going to be hard. You know?
Takes a while.
Yeah, exactly. It takes time, and well, what do? I design it, then I build it, then I test it, then I use it on the moon. Oops, didn't ever work quite right, so I redesign it, then I retest it, use it on the moon again. It's an awful lot of years that have gone by in the process of doing that. And that's not what I want to do. I want to be able to do this quickly. I want to be able to do it commercially. I want to generate very large ROI. My best guess is that after about 10 years, you got something in the order of $100 billion a year in income, maybe 10 billion a year in expenses. I mean, those numbers aren't very precise, but you know, you've got a lot of margin, let's put it this way, of income over expense. And that's what I want, because I want to generate ROI, because I want commercial people to go out and be able to do this, that are interested in making money. And quite frankly, people who want to make money don't tend to be your age. You are relatively young. The people that have a few tens of millions of dollars to go invest in this are older. They don't want to wait 30 years for return on investment. Right? They would like to have return on investment in 5 years, 10 years. They want to be able to enjoy it.
Right.
Does it make sense?
Yeah, absolutely. I very much appreciate your comments. I think others on the call also had some questions, so be just happy to turn it to them.
Thank you very much for your comments. I appreciate it. By the way, I hope you enjoyed JPL.
I did. It was some of the best years of my life. So
great. Glad to hear it. Our daughter enjoys it very much.
Oh, yeah. We all did.
Thanks a lot, Nimisha. That was a really, really insightful conversation. We still do have a few questions, but I want to ask you, Dr. Wertz, if it's okay to be mindful of the time, if it's okay to take the questions, or how should we go forward?
Certainly fine with me. I have no problem. However long. I enjoy the conversation very much. This is, I think, very valuable all the way around. I'm appreciative of the conversation. As long as you want to keep going, it's fine with me.
Thank you. That's very, very kind of you. A couple of people recently joined just a few minutes ago. To update you, we are talking about a very interesting concept, which is the social part of building a lunar civilization. And there are some interesting questions coming up. If you want to ask a question, but if you're not comfortable being on the recording, please ask your question on the comment box. But if you're free to be on the recording, then please unmute yourself or switch on your camera and go ahead and ask your question. We have one question from Kaustubh Ghosh, and he wants to unmute himself and ask you directly. Please go ahead, Kaustubh.
Sir, I am Kaustubh Ghosh. I am currently working in RF domain in Samir.
I'm sorry, working in what?
Sir, in the radio frequency domain.
Okay.
Mainly in the circuits and systems division. And my question is that for the cost-effective space mission, apart from the 3D printing, what other techniques are there that can reduce the cost and the weight of the components? Yes, sir.
I didn't understand your question.
Sir,
I apologize.
For the cost-effective space mission, apart from the 3D printing, what other techniques are there that can reduce the cost and the weight of the components?
I think one of the main drivers for reducing much of the cost is going to be what we talked about earlier. That is to say, AI and software activities. I think a large fraction of what is being done can be done in software. If you think of a traditional spacecraft, a large fraction of the components of a traditional spacecraft, where the communication system, for example, had often well more than half of the components on the spacecraft. What I can do is eliminate a lot of this by doing a lot of processing on board either the spacecraft or on the moon, whatever it is, and using both generic software and AI software, both, to do much of the analysis to eliminate much of what has been done. Let me give you a specific example. FireSat is the example in that the SMAD book has used for 30 years now as an example of a mission. Well, actually launched it. Who knows? What an amazing thing. FireSat is now a real live critter. There've only been one launch. They're going to be 50, I guess, in due course. But a large fraction of what it's doing is it's using AI to identify forest fires. And that enormously increases the amount of work that can be done. Instead of having to send all of the data down to the ground, I can now do a lot of the processing on board the spacecraft and say, oh, there's a forest fire of this magnitude at this latitude and this longitude. Now that's an easy thing to send down. And I can send that down directly to some guy driving around in a truck. Right? He doesn't have to do the analysis. The analysis is getting done for him. It's being done on the spacecraft relatively early in the process. And so that increases, it doesn't directly reduce the cost. Instead, it increases the performance capability, which decreases the cost per unit of performance. So as a consequence, that I think is a major advance, to say the least, in what it is that I'm going to be able to achieve. And in any spacecraft, I think that's going to be a huge help, particularly with small spacecraft. Now your small spacecraft is, size of a basketball or something similar. And it can be very small and can be extremely capable. And that's what I want to do, is to provide capability in small size. Does that make sense?
Yes, sir. Thank you, sir.
Sure.
Thanks a lot, Gustav, for asking that question. Our biotechnology student who asked that very interesting question, the first one says thanks and says, do you think biotechnology integrated with satellite systems could revolutionize how we detect emerging diseases and track genetic changes in crops globally?
Ooh, that's a tricky one. I don't know whether it's good or not, but I would argue that it is certainly worth exploring. And again, I need to be able to explore these things by doing them in some reasonable quantity. I mean, I can't do this in something that's the size of a room that you're in or that I'm in. I have to have actual space to do stuff. I've got to actually run experiments. I mean, there has to be some real science here. And that means it needs to be obviously run by scientists. And second of all, it needs to have enough room to make it occur. And so therefore, I think it's an interesting question, that it would take a little bit of work to sit down and think about, how am I going to learn this? But I do think that, yes, we can learn a huge amount. There is a lot of very real and very compelling science that can be learned here. And obviously, I mean, I guess it's good, but we have only one environment right now. We've got 1G, we got an Earth environment. It's one Earth, we all got to use it. As I start to go into space, there are a variety of environments that I can create, or that exist naturally. Clearly the lunar environment exists, the space environment I can create, and so on and so forth. I can use these, and I can use these to get dramatically better science. I mean, I look at space as being interesting, looking for life in the universe and stuff like that. So the one that I think of personally is the observatory on the far side of the moon, because now I don't get all of the radio noise from the Earth. I don't get any of the light pollution from the Earth. I don't have any atmosphere that I have to look through. I can build pretty much as big a telescope as I want to build on the far side of the moon, and I can start to begin to explore the rest of the universe. Is there life out there in the universe? Clearly, one of the key science questions we want to ask. And I think there's a far higher probability of being able to answer that question from both a radio and an optical observatory on the far side of the moon. Would be a neat place to be. Does that make sense?
That's definitely a lot of work opportunity coming up for researchers. A very interesting field. Thank you. Thank you for that very nice answer. We have one more interesting question is, I can see that you are very much full of energy and passion. For sure, I agree with you, the person who asked this question. What is the most important thing which you still want to study or solve?
I guess to me at least, having now taught this course at USC for a period of time and switched over to starting looking at the moon, the thing that I would like to do is to convince enough people to make it happen to truly make a lunar colony come into being. To have commercial community put up, I don't think, frankly, a lot of money. I don't think it's a huge amount of money. I mean, it's in the end, it's going to be tens of millions of dollars, but there are lots of things in this world that cost tens of millions of dollars. And actually get started building a near-term lunar settlement, because I believe it would be truly a fascinating place. And to make that come about, I think would be, I don't know, a pretty good accomplishment, let's put it that way, to truly make something occur and to begin to look at the world and the solar system in a different way. Someone just mentioned in one of the previous conversations, the social versus technical approach. And I think that's correct. That is the right way to look at it, that there is a social aspect to this. It's not just technology and science, which is not to say the science isn't interesting. It is, clearly. It has enormous value. But so do the social aspects of it. Being able to look out into the universe and recognize that people are beginning to expand into the solar system. And by people, I mean people, not astronauts, not selenauts. My comment is a few less naughty people. The needs to be just you and I type people that are looking at enjoying life, living in a different way, and expanding into a different aspect of the solar system. There you go.
That's such a wonderful answer. The response is, James, thank you so much for the inspiring answer. Thank you for the good question too.
A very good question.
Thanks. One person had to leave. He's actually one of my professors who helped me learn about space mission engineering, and SMAD was part of the course that he taught. And he said, I have to leave now. Really enjoyed it. Thank you, Dr. Wertz, for the engaging and stimulating conversation. Thanks, Shumana, for hosting. So may I ask you one question if no one else has any more questions? We can certainly take, if anyone has an interesting question related to this, please feel free to ask. Until then, my one question that came to my mind listening to this lovely conversation is that, Dr. Wertz, hypothetically, when you mentioned that there'll be representatives of countries going to the moon and helping people from there, we get this question a lot: why go to space when we have so many problems on Earth? For example, we are building civilization, and it's so nice to see that we are trying to include everyone in the process. In case this actually happens, that state representatives tell us the benefits of what they see of living on moon may be, and they get a question from a person on earth saying that, you represent my country and I am in so much trouble in my country, why are you spending our resources and time going to the moon? It could be a controversial question, but what do you think
No,
could be an answer?
I think it's a very good question. I think it is indeed a very good question indeed. And remember, the cost here for an individual country is going to be, oh, I don't know, let's say somewhere between $5 and $20 million a year, something of that sort. That's roughly the cost of maintaining an embassy somewhere. My guess is that the Indian embassy in the United States probably spends more than that. So the cost, in fact, is very modest. And I think the return is very substantial in the sense that it lets India, for example, be a part of the expansion into the solar system and looking to grow, to find new lands, new areas, new information, new science, and some of which is going to be applicable back on Earth. Remember, in the moon, my lunar settlement, for example, I've got a problem. I've got potential pollution problems. I've got thermal problems. All of those problems are going to exist in the moon. And clearly, I'm going to have to find a way to keep that lunar settlement, to keep the air reasonably clean, the water clean, stuff like that. I can apply those same technologies back on Earth. They are applicable, if you will. The Earth is simply a very big lunar settlement. I've got to find ways to work pollution problems, for example, to work growth problems for plants and animals. All of these things are important, and the moon and space are both excellent environments. They have to be big enough to allow it to be able to actually develop some of these technologies. But these technologies can be germane to making life much better for your colleagues back on Earth. So yes, I think both the science is there, the psychology is there. Is the Earth going to be the right place to do everything for the unlimited future? I don't know. I mean, it certainly looks like, I don't know about India, but the United States certainly has pollution problems, has difficulties. And how do I find ways to begin to resolve those? And this is a good way to start doing that at, frankly, very low cost relative to most other things that are getting done.
Thank you. Thank you so much. That was such a fantastic response. I could have never thought about it that way. We have a comment. Thank you, sir, for your thoughtful answer, as it opened my mind to new and exciting possibilities where biotechnology and space science can come together.
Fantastic. I'm glad to hear it. I enjoyed the conversation, by the way, very, very much. And again, I really would like to find a way to get some graduate students in the graduate class. By the way, most of the students in my class are remote anyway. I mean, there are a lot of them in Europe and around the United States. So doing things remotely, that's, I don't know, I'd say 80% of the class is remote. It's only about 20% of it that actually physically sits in the classroom. And I would be delighted. And I don't know. Not only would I be delighted, I think it would be a major contribution to the class to have 3 or 4 graduate students from India. It would be a huge help in bringing a different perspective. And again, it's that perspective that has value and would be greatly appreciated. So by all means, don't know how to make it work yet, but I'd love to find a way to make it work. I think we could find a way to make it work without any real trouble. So would love to do it. And thank you very much for your kindness in accommodating me for probably talking too much, and I apologize.
Thanks a lot. I'm truly, truly grateful to you. And this is like a dream come true moment for me. And your work has been one of the major inspiration for me, and I know for many, many people around the world, to actually understand how space missions are designed, feasible, affordable space missions are designed. And we have learned so much about a very difficult subject, which is orbit management and ADCS. So thank you so much for your work and for what you're doing even currently. I'm sure when we put this up on YouTube and Spotify, many people would be interested in joining your class.
Thank you very much. I appreciate the conversation very much. And I hope things go well for your future podcasts. It sounds to me like you've got a remarkably interesting program there.
Thank
And
you.
I appreciate being able to be a part of the conversation.